In reviewing the wealth of photographs, newspaper clippings, and other historical documents that the United Water Conservation District has amassed over its 90-year history, we came upon this film, Our Valley, which we'd like to share with you now. Originally produced in 1955 to document and celebrate the completion of the Santa Felicia Dam, this entertaining piece of our history proves that while our world has definitely grown more complex over the last 62 years, many of our water issues remain unchanged. While we're still addressing seawater intrusion on the Oxnard Plain, recharging our aquifers through fast, percolating basins of Santa and praying for rain, we also embrace technologies that provide more accurate, real-time water use monitoring, collaborating with our neighboring cities and water districts to enhance our water supply with both recycled and imported state water, and encouraging the best water management practices that will continue to help us achieve groundwater sustainability for hopefully another 90 years. For now, however, join me in taking a look back at the good old days of 1955.
This is the valley of the Santa Clara. It lies between the inland desert and the coastal plain in Southern California. Settled by pioneers, it is today a land of many things. Of oil wells pumping their black gold high on South Mountain, and down on the valley floor. Of industry which flourishes in the rich lower valley and on the coast in the Oxnard area. It is also a land of friendly villages, of busy towns and cities. And of gracious homes nestled in the foothills and spreading among the green fields. But most of all, it is a land of prosperous agriculture, of farms and orchards, of avocado groves and field crops. The valley grows these crops in lush abundance. Oranges from near the towns of Piru and Fillmore, in the upper reaches of the valley, are unsurpassed. Santa Paula boasts of being the lemon capital of the world, producing with the rest of Ventura County 1/5 of the nation's lemons. The Oxnard Plain produces a multitude of crops, fruits, vegetables, and flowers, food for the table and food upon which to feast the eye. Often 3 crops a year are grown on this land, with harvesting by hand, by power machinery, and by our allies, the bees. The pioneer is gone, but still the valley grows. New plantings of avocados and citrus fruits push further up the valley sides, while on the valley floor, fertile farmlands give way to the builder as more and more people find their homes in this pleasant valley of the Santa Clara. And as the valley grows, so grows the need for water, for orchards, and for field crops. It is estimated that of all the irrigated agricultural land in Ventura County, more than 3/4 lies within the valley. City and industrial requirements for water are ever increasing as the valley's economy expands. New wells, new pipelines, new water tanks, and reservoirs spread out across the valley to meet this need. But the demand grows, and daily more water is being drawn from our priceless underground reserves than nature is able to put back. Without some plan for aid, the valley cannot for long continue green, living on water from the past. Many years ago, the people of the valley began a conservation program to divert the water from the flowing streams and put it into basins where it could percolate into the underground and thus be saved for future needs instead of wasting to the sea. In 1927, such a basin was built near the town of Piru, California. Later, in 1928, another spreading ground was built near Santa. Both of these works are still serving the valley well, but needs have gone beyond the limits of surface diversion and spreading. The big floods cannot be spread. Other means for their conservation must be found. The United Water Conservation District was formed in 1950. Plans were made for dams along the tributaries of the Santa Clara River, where floodwaters could be held back and later released to replenish the underground storage and to supply still more water through pipes across the valley. The original plans envisioned complete development of available resources with at least one storage reservoir on Piru Creek and perhaps two on Sespe Creek and necessary auxiliary works. In the fall of 1953, a bond issue for $10,939,000 was voted for the first step of the ultimate plan. Designs were completed and construction was underway in the spring of 1954. This first step consists of a 100,000 acre-foot reservoir on Piru Creek, over 15 miles of pipeline, and spreading areas, wells, and pumps in the Oxnard Plain. Here on Piru Creek is the Santa Felicia Dam. Water stored behind this dam will be released to flow down Piru Creek to join the Santa Clara River near the town of Piru. Some of the water will enter the spreading grounds here, and the remainder will flow down the river past Fillmore and Santa Paula to the diversion works at Santa, replenishing the river gravels as it flows. At Santa, part of it will percolate into the underground. The remainder goes by a pipeline down Ditch Road to Central Avenue, where it divides, one branch going to the El Rio spreading grounds, whose wells pump water to Oxnard and Port Hueneme. The other branch follows Central Avenue to the Pleasant Valley Terminal Reservoir for distribution in private pipelines. The first major structure to be started was Santa Felicia Dam. Here on Piru Creek, some 5 miles from the town of Piru, California, between the wide-plung canyon walls, workmen and machines have labored mightily to strip the growths from the valley walls and floor, to dig a deep trench reaching to the bedrock beneath the stream bed, and then to bring a safe and solid dam from bedrock to the valley floor and on up the canyon walls to the crest of the dam. This work is being accomplished in several steps. Here is a section representing a view of the dam site from downstream. First, the trees and brush are stripped from the valley floor and walls, and then the material from the riverbed is excavated to form a wide trench from side to side of the valley. After the river sand and gravel is removed, the foundation is treated with grout, a mixture of cement and water pumped into holes drilled in the rock to seal off all the cracks that might be in the rock and thus stop any chance of water flow. The side walls of the canyon are then stripped of excess material, and the core and shell material are brought up together to build the dam in stages. On April 23, 1954, attended by members of the Board of Directors, interested citizens of the community, members of the press, and the staffs of United and the construction contractors, groundbreaking ceremonies for the Santa Felicia Dam took place, with a tractor and bulldozer starting the clearing of the riverbed. Pleased with this action, the people posed for press photographers. Director Bob Nauman of Pleasant Valley assisted the ceremony by climbing on the tractor himself and pushing down a tree or two. few days later, the valley floor is bare, and an army of heavy construction equipment moves in. Scrapers dig into the river gravels from the core trench and carry it to the embankments where it will form a part of the dam. In places, bubbling springs of oil along the foundation create problems for the engineers and workers. The material grows darker due to oil as the excavation is carried deeper, and some of it must be placed in waste piles instead of in the dam. Day and night, the mighty machines labor, load, haul, dump, load, haul, dump, until some 80 feet below the riverbed, the clean, bare bedrock is exposed. Next comes the building of the watertight central core. From a borrow pit upstream in the reservoir area, clay of excellent quality is excavated by scrapers and by Sierra loaders. The material is then hauled downstream to the dam. On arrival at the dam, the material is spread, moistened if required, and then compacted with heavy rubber-tired or sheep's foot rollers. Regular laboratory tests ensure uniform high density. The hauling equipment then returns to the pit where it is loaded and starts a new round trip. And so it goes. Load, haul, dump, spread, roll. And then there comes a day when the great hole is filled and the structure starts growing up above the valley floor and against the canyon walls. From the stream bed borrow pits, gravel material for the pervious shells is loaded and hauled and placed in the dam against the central core. Banked against the watertight core, the sand and gravel from the riverbed provides the buttress and the strength for safety and stability of the dam. And so each day brings nearer the time when the dam will block the canyon and cut off the flow of Piru Creek, except through the outlet valves. Meanwhile, high up on the west wall of the canyon, a great gorge is being cut to provide the spillway flood channel past the dam. On this structure depends the safety of the dam, so a scale model was built on which the engineers could observe the way the spillway works and make changes to improve the efficiency of the flow. The waves, which you see here, were eliminated by design changes in the walls and floor. The model was built to 1/50th of final scale. On the ground, the spillway itself will measure some 480 feet from wall to wall at the crest, lying in a great fan-shaped structure, narrowing as it approaches the downstream end. A cutoff trench running the full length of the crest is carved into the solid rock and backfilled with concrete to prevent water from seeping beneath the structure. Washed sand and gravel aggregates for the spillway concrete come from a plant in the valley far below. They are hauled up the steep face of the dam to a mixer in the spillway area. The concrete for the floor of the spillway channel is placed in forms and carefully vibrated into place. The top is then struck off with screed boards and allowed to set. When it is aged sufficiently, workmen with power trowels provide the smooth, dense finish. But skilled workmen with hand tools still provide the final touch. Massive walls as high as 40 feet above the spillway floor are then built on each side of the channel to guide and hold the flowing water at flood stage. The design capacity of 105,000 cubic feet per second is approximately 3 times the maximum flow ever recorded in Piru Creek, thus affording a tremendous margin of safety for the dam. And so we have the finished dam and spillway, cupped across the valley like a protecting hand to store the floodwaters and keep our valley green. In the meantime, far downstream from Santa Felicia Dam, the diversion dam and dikes for the spreading grounds at Satacoy are strengthened and rebuilt, and a wasteway is added. Huge pipes are joined to the system for diversion of the river to the spreading grounds and to the fields below. A new spreading ground is being built near El Rio so that even more waters from the floods that are saved can be placed in the underground to help renew the never-ending stream which surges out from the flowing wells. Here is the cycle of the use of water in the plain. Water falling on the soil in the form of rain or carried down the river and diverted as stream flow enters the ground and follows down along the gravel beds. The flow goes outward toward the sea, and into these freshwater beds are drilled the wells for the farms and cities. So long as the water coming into these gravels exceeds the amount taken out through wells, the plains are safe. But in recent years, the water use has increased so much that near the ocean's edge, the salt water has intruded. A prime objective of United's program is to stop this inland invasion. Santa Felicia is a step in this direction. But with California's growing need for water for its expanding population, more must be found, perhaps brought in from far away, or perhaps within the valley itself. Here in Sespe Canyon, a tributary of the Santa Clara, is the Topa Topa Dam site. Sites for other dams have been found at Blue Point and at Cold Springs. Each in its time must be developed, and when these things are done, there still will be the need for water from the great rivers of the north to match the surging growth of Southern California and of our valley of the Santa Clara.